Hello learners, I welcome you to Dr. D.Y. Patil Vidyapeeth, Pune. My name is Professor Toshi Dave and today we are going to cover unit number 2. The title of the unit is Data Preprocessing. In this unit, we will encounter certain concepts about data preprocessing, like what is data preprocessing, why we need it, what are the techniques to implement data preprocessing, and what are the steps to conduct preprocessing. Apart from that, we will also come to know what is feature scaling, what is the need of it, and how to implement feature scaling in machine learning. Coming to the very first concept, that is, what is data preprocessing? As the name suggests, that we are going to process the data. Why it is we are using the term preprocessing? Because we are going to build a model on our data set. So before building a model or modeling a model, what we do, we will cleanse our data, and for that we have to follow certain procedures. Fine. Now, why we are cleaning our data? Because in real world, our data set contains many flaws. There can be many data whose values are missing, or their value may be wrongly input in the system. So, for this certain reasons, we require data preprocessing. Data preprocessing is nothing but the process of transforming the raw data into understandable format. We are calling it raw data because from wherever we gather our data, from wherever we collect our data, that data is not appropriate, that data is not accurate. To make it accurate, to make it consistent, to build a proper and appropriate, perfect, accurate model, we require data preprocessing. Okay, and it is a very important step in machine learning. Now coming to the need, that why we need preprocessing, the very first is we want that our data should be correct. To ensure that we do preprocessing, our data should be available. We have to check that whether our data is complete or not. Next is consistency, which checks that whether the data at all places should be same, and also it should be updated correctly, that is timeliness. Our data should be reliable, and because we are going to build the model on that data, so for our understanding, our data set should be in that format. That is, it should be in the understandable format for the one who is going to build the data. Okay. Now, the next is steps for preprocessing. Now, following are the steps for preprocessing the data. The very first step is, first we need to import the libraries, and after that we have to load the data set. If required, conversions of the data type will be done in the data set. Then we will treat the missing values, as well as we will identify or detect outliers, and accordingly we will give treatment to the outliers. Next is scaling the numerical values, encoding the categorical variables, and if required, we will create new variables also in the data set. And at the last step, we will split our data into train and test model. Now we will go in depth with each of these steps. The very first step was importing the libraries and loading the data set. The basic library required for data preprocessing is none but the pandas library. For that we have to write import pandas as PD. Okay, why I am talking about panda library? Because panda library is used for, in Python, panda library is used for data preprocessing and to analyze the data. So for that we have to load panda library. Apart from that, as much as we dive deep, we will require certain variety of libraries also. And also to load the data set into the Python, we have to import the data set. Also for that we will require panda library. So Here I had written certain coding statements from Python here to import the CSV data file, that is comma separated value file, which is nothing but the Excel file format. So here how to import the data set into Python, I had just written the statement like df is equal to pd.readCSV, and in readCSV is the function name which will contain the file path where that data set is actually locating or residing in our system. Fine. Now to display the first 5 rows of our data set, we have to use .head, that is df.head function. It will display the first 5 rows because the data set is having thousands or lakhs of or millions of records in it. So it is not possible for us to view each and every record. What we do is we just take a snapshot, or I can also say that we just take a little bit or only 5 rows to view that how data looks like in the data set. For that I had used the head function, and if I want to collect the information about data set, like what is the dimension of it, if I want to know the dimension of the data set, for that we have to use df.shape method. Next, if I want to know that what are the standard deviation or any of the mathematical or statistical stuff I want to know, for that I will go with df.info method. Next is converting data type. Here, because we are going to build the model on the data set, so for that we require that all the column names or all the columns containing value should be of same type, same data type. Okay, for that we have to convert the data types so that a common data type will be among all the parameters or all the columns, so that we can build a model on it. For that, before converting data types, we have to check what are the available data types our data set is having. For that, we have to use df.dtypes. Okay. Next is data type conversion. To convert the specific data type into another data type, we have to use df column name equal to df column name dot s type, data type name. S-type is the method in Python which allow the user to convert a data type into another data type. Fine. Now, the next step is the treatment of missing value. Generally, in our real world scenario, our data set contain missing values in form of either the missing values will be allotted or assigned null NULL, or there will be blank space. So to identify those missing values, Python is having a method, that is null method. And to calculate that how many null values are there in our data set, we have to use sum method followed by after isNull. Okay, so for that df.isNull.sum will give me all sum of all the null values available in my data set. Now, to treat those null values after detecting how many null values are there, what we have to do is, if there are very limited number of null values in our data set, then what we will do is we will drop those rows with missing value. And if there is a majority, that there are a majority of null values in our data set, then we have to treat them separately using certain different algorithms. Okay. Now, the next is outlier treatment. What is outlier? The very first thing. Outlier is an observation in the given data set that lies far from the rest of the observations. Now, to detect it, before treating the outlier, we have to detect it. And for that, we have box and whiskers plot. The next is z-score, and the last is IQR, that is interquartile range. Using any of these three techniques, we can detect the outlier, and based on that, we will give a proper treatment to our outlier, that whether we want to ignore it or we want to get those observation on the same scale. Okay. Now, the next is scaling the numericals. Now, Scaling is required because we are going to build the model on our data set. Now, the thing is that not all the observations in our data set are on same scale. Okay, so for that what we have to do is we have to scale the numeric values, and for that we have two techniques. One is standardization and the next technique is normalization. Now for standardization, in standardization what we do is we try to fit our data according to standard normal distribution. And in standard normal distribution, there is a distribution with mean of 0 and where the standard deviation is 1. So basically in standardization our value will range between 0 of mean and standard deviation will be around 1. In case of normalization, it is again a scaling technique, and here we shift our values and rescale so that they will lie between 0 and 1. Here 0 and 1 are not associated with the mean or standard deviation. Fine. Normalization is also known as min-max scaling, and it is useful when the distribution is unknown or not Gaussian. Next step is encoding the categorical. It is the process of converting categorical values into the integer values. And why we are doing so? So that our model can provide improved predictions. And this is why we are performing this step of encoding categorical values. Next step is creating new variables. Here we just add new columns to our data set so that we can understand the data set properly. And the last step is splitting data set into train and test set. Now, because we are talking about the supervised learning, in supervised learning, before building the model, what we have to do is, first we need to cleanse the data set. After that, we have to divide our data set into two partitions. One is the train and other one is the test. And the percentage for train and test data set is either it would be 80 and 20, or it would be 75 and 25%, or it is 70-30%. Now, majority of the data set will be used just to train the model. This is why it is known as train data set. And to predict that whether that data set is appropriate and giving accurate and appropriate, it is whether or not it is predicting appropriate values or not, for that we are keeping a very little amount of little percentage of our data set, that is 20%, 25% or 30%, which is called as test data. So after making or building the model after training the model on the trained data set, we will implement that model to predict the values in the test data set. So based on that, we will identify that whether or not our model is appropriate. Next is techniques for data pre-processing. The very first is data cleaning. When we are talking about data cleaning is also nothing but the part of data pre-processing. So here also we try to identify the missing data or values, that is null values. We remove the noise from the data, that is repetitive value. We have to remove the duplicate data. We have to make our data set in consistent state. Then we have to give proper treatment for outlier. We have to remove the redundant data, and after removing the redundancy from our data set, we have to bring our data in consistent stage. Okay. Next technique is data transformation. Data transformation means here we will convert our data or transform our data. Okay. So for that we will use feature engineering. We will deal with categorical data. That is, again we are converting the type of data types. Then we have to deal with imbalanced data, and also we have to deal with numerical data. Why we are doing data transformation? Because we have to build the model. Keeping this in mind, we are performing steps, we are implementing the techniques for data pre-processing. And based on this, we are cleansing our data as well as transforming our data. Next is feature scaling. Feature scaling is also known as variable transformation. Why it is necessary? Because our real world data set is having different magnitudes, ranges and units. So what we want is each of our parameter, each of our column should contribute to build a proper model on that specific data set. See, if you are making a model on specific data set, it does not mean that that model is also applicable to other data sets of real world also. It is not like that. For each data set, we have to build a model using different algorithms of machine learning, artificial intelligence. Okay, so depending on the variety of data set, we perform different steps for data pre-processing. We implement different techniques for data pre-processing. It is not like every data set may contain, there is a probability that there may be no null value in a data set, there may be no outlier in the data set. Now, the thing is that it is hardly we found such type of data set. If you are founding such type of data set that such data set is having no missing value and no outlier, then you are fortune. Fine. Now, to ensure that machine learning models can effectively interpret these features on a consistent scale, it is essential to perform feature scaling. Now, to implement feature scaling, we have three techniques. The very first technique is known as min-max normalization, which is also generally known as normalization. Here, what we do is, we rescale the feature with distribution value between 0 and 1, and the formula for performing min-max normalization is x dash is equal to x minus minima function of x upon divided by maxima function of x subtracted by minima function of x. This x is nothing but the feature, or we can say that it is the parameter or the name of our column in our data set. The next is standardization. Here again we are rescaling the feature, but here we have to make our feature, or we have to rescale on normal distribution, based on normal distribution, standard normal distribution. So here we have to go with 0 mean value and variance equal to 1, and the formula for standardization is x dash is equal to feature dash is equal to feature subtracted by the feature bar, which is nothing but the average of the feature value, and divided by standard deviation of the feature factor. Now, the last but not the least is log scaling. What we are doing is we are rescaling the feature so that we can build model on it. Log scaling ensures that we have to make our values, if the values are of wide range, we have to make it small so that it would be easily appropriate to build the model, and we can easily recognize the values for that specific feature. Okay, so the formula is x dash is equal to log x. It will reduce the wide range to a small range. This was all about data pre-processing. Thank you for paying attention. Thank you.